Today I'll be discussing Beyond Spatial, which is my final project for AME 530, Philosophy of Media Technology. Beyond Spatial is the concept for blending digital and physical spaces. Let's discuss the project's conceptual core. Spatial by definition means connected with space or position and area of something. Beyond spatial means moving past the traditional understanding of media in physical space to incorporate additional dimensions which can be emotional, sensory, contextual, or virtual into perception and interaction. This was the concept that I proposed during the midterm presentation. The goal of the project is to use physical spaces as canvas for digital experiences, which creates a seamless blend between physical spaces and digital spaces, which utilizes the capabilities of modern game engines to create any and all sorts of digital experiences on the physical captured canvas. Let's discuss the project challenge and the design solution. The challenge is to capture the space and use it as canvas with digital assets, which allows 9 degrees of freedom for multiple users at the same time using VR and AR headsets. This allows enhanced collaboration, creates immersive environments, and the project also aims to solve limitations of existing systems. The design solution for this particular project includes creating a physical rig of Azure Connect cameras that can accurately capture a 3D physical space, represent information as point cloud in Unity, and use Meta SDK for creating AR and VR experiences as the primary medium of realization. This project is this project revolves around two main readings and discussions. One, The Language of New Media by Lev Manovic, which which suggests that any new media is a convergence of two separate historical trajectories. New medias are not fixed but exist in potentially infinite versions due to their variability, and the forms that associate with new medias are extensions of existing and older medias. He suggests 5 different principles of new media which I have tried to add into my prototype. The other reading is the participation to interaction towards origins of interactive art. This particular write-up by Sok Dinkla discusses how technology forms new types of interactions where audiences are co-creators and they have more agency in the experience rather than being the passive recipients. I've tried to use people as an object inside the experience that I'm making, which makes them part of the experience. Let's discuss the project's approach and what makes it creative and innovative. This particular concept has three major um, advantages. One is the medium of realization. In the readings, we read how distribution of media plays an important role. And because I'm creating this particular project in Unity, the distribution of this experience makes it easy and fast. And we can publish the same experience for PC, mobile, and AR/VR devices. The second is multi-user interactivity, which allows multiple users to be part of the same shared real-time experience, enhancing collaboration and interactivity. The third is real-time data processing, which involves audience to be part of the experience and increasing their involvement in media and the interactions that they do inside the project. Let's start and see the demo of the prototype. This is the early realization of the project in which I am trying to see the point cloud using one Azure Connect camera. The point cloud on my right is what is being presented on my headset, and you can see that I'm testing the latency and effectiveness of the capturing method. The final setup was made using 3 Kinect cameras placed on the rig, and we can see that I'm using the yellow box as the object that I am going to use throughout the experience. All the 3 cameras are projected in the triangle space, which makes it easy to capture the space from all directions. We can use more cameras if we want, or we can also replace cameras with anything else instead of Azure Connect. Here I'm showing how I'm moving the object in my physical space and it reflects directly with no latency in the digital space. As I'm putting the object down, we can see that in the space the object is kept down and it comes up. I've also added the transitional, rotational, and scaling movements, which means that we can use the joystick to move around the game object and it allows us to interact with the physical space and use it as an element for our AR and VR experiences. This means that anything that is possible using the Meta SDK and game objects can be done with the space, creating more immersive experiences and more interactive experiences, which can improve the narration and storytelling, or which can also improve how we experience any sorts of media. One of the recommendations was to add digital assets by one of the classmates during the project proposal. In this part, I have added a cube just to experiment and test whether we can add 3D assets, which in this case works, which means that we can add 3D assets on top of the physical space and we can render them in the project. We can also scale the object, in which in this case I'm scaling it up and down, and then I'm also translating it around the space, which means that I can create an alternate reality right next to me in which I am in the digital space, and that can be one immersive experience by itself. The last thing is changing the media on top of the overlaid physical space. So here we can see that I'm moving the object in Unity, and we can see that object moving live on the physical space, which means that we can animate and we can create all sorts of experiences along with the game object. There are three main design principles that were introduced in the course that I liked. One was to create new media with the familiarity of old media, which means that any new media that is being created has to be an extension of an existing older media. In my case, it is an extension of existing game engines and point cloud rendering, which are integrated together and displayed in an AR VR experience for collaborative purposes. The second is that media objects should be composed of smaller independent elements that can be combined or reused. In my experience, the physical space is used as a game object, which is an element which can be reused for multiple experiences, and plus we can use it with other game objects inside the experience, which makes this media more accessible and more reusable. And the third is media should transform and activate urban spaces, fostering community and interaction. In this case, the author discusses about physical spaces in real world, but I kind of like the design principle in which I can use the captured physical space and put elements inside, which can serve as background for all sorts of information that I want to overlay. For media formats, this media is kind of an intermedia, which is very difficult to define under which category this falls. But I like the responsive media and interactive installation media formats in which people are part of the experience, as well as the experiences are more immersive and people have to actively participate in that experience, and the experience is dependent on their movements and their interactions. The second media format was ambient media, in which Anna McCarthy discusses how physical spaces can be used as backgrounds for overlaying more information, and that enhances our experience. In the same case, I can create an experience and environment with digital information overloaded on the physical space, which is on the backgrounds. And this type of media can be used for entertainment and all sorts of different purposes. This concept is a progression from static and linear forms to dynamic and interactive systems. The new type of media is an extension of multi-screen videos, which takes inputs from multiple angles and recreates it into a 3D space, which makes it easy for people to freely move around and experience that thing in real time. Does the project achieve significant goals that could not have been realized on paper? Yes, the project achieves goals for real-time streaming, and it is being displayed inside an AR and VR headset, which makes it very difficult and rather not possible to realize on the paper. And yeah, for research data and research depth, there were three primary objectives: system requirements and setup, which revolved around hardware and understanding different types of sensors, understanding software and existing solutions and their limitations. The second was exploring methods for 3D capture and reconstruction and visualization. which included how to set up the project with Connect Azure, Unity, and Meta SDK, and how to use different rendering techniques for quality and experience. And also, what are the problems with live streaming and how can artifacts and bandwidths be improved? And last, real-time data processing and how can I create the type of experience I did with the best human-computer interaction systems to create a real-time volumetric capture. While doing the research and understanding the existing process, I realized that all projects kind of are encapsulated in these 5 steps. Calibration is synchronizing of all the hardware devices to overlap the transitional and rotational information of each camera to retrieve color, depth, and point cloud information and overlap them on top of each other. I have used 3 different images that uses the same concept to overlap point clouds for um, calibrating and creating a point mesh. These are different types of capturing systems. They use different hardwares. They are used for different types of purposes with different fidelity. And in my case, I'm using the Kinect, so I'm using K4A, but it depends on what hardware you're using and the medium of visualization, which changes the capturing methods and techniques. For game engine, any software or language that can process 3D data is used to visualize the captured information. The choice is made based on the use case, primarily being Unity, Open3D, Unreal Engine, or WebGL. For rendering, there are 4 widely used techniques. One is point cloud rendering, which I'm using. The second is mesh rendering, then we have 4D Gaussian splats and photogrammetry. For visualizations, my research more mainly focused on systems that are based on Unity, and for them they get data directly from Kinect, or they stream the point cloud directly from Kinect by aligning it with the color texture. The research sources and mediums are distributed among research papers, documentations, website articles, tutorials, which are listed here. Coming to the design decisions and challenges, the design decisions change throughout the course of the project development to achieve the goals for the prototype. Every decision was compared with alternatives and implemented after testing. The design decisions were deliberate and controlled. However, there were 2 significant challenges. One was the archived SDK, which was not which is not being actively maintained, which became a challenge for me to use it with the latest Unity versions in the Meta SDK. So that was a little challenging. And the other thing was the calibration was not accurate, which means if we look from a certain angle, the visualization was very refined. But when we move closer, we could see that there are a couple of points that are offset or that are not overlapping correctly, which needs to be refined further. The narrative of the project is pretty simple. It is to capture and stream a space locally that can create and capture every angle, every gesture, every emotion, and recreate that thing in real time, which can allow us to visualize in 9 degrees of freedom, which can improve storytelling, collaboration, training, and bridge the gap between physical and digital spaces. Is this reflected in the content, in the concept? So yes, the project captures a live space and that is being streamed locally on my headset using Point Cloud as interactive game object, along with Cube as additional digital asset. Is it useful? Primarily, this type of technology is useful for live conferencing, remote collaboration, for filming and media post-production, for game development, or maybe marketing, sales, and training, or anything and everything in between. Regarding progress, this project was spanned across 5 weeks, where first week was learning about the hardware and how it can be integrated. The second week was more research oriented, where I focused on the technical requirements and everything that I need to put up together to create this experience. Third week was understanding the data flow and creating a touch designer experience to create a point cloud to understand how the data is flowing and then start creating that thing in Unity. In the fourth week, I started testing with the system with one camera and with multiple cameras and integrating that with the Meta SDK for 9 degrees of freedom and which allows multi-user experience. And in week 5, I was able to record the entire tutorial and document the process. When we come to feedback, the feedbacks were sought over 3 lectures and via email to understand the concept and how to think about the final presentation and also clarifying doubts. The two major feedback that I got from the instructors was to think more philosophically about the concept and how it is unique and makes it what makes it advanced media. The other was to articulate the idea clearly and structure the scope of the project. Um, Based on the inputs and suggestions that I received by professors, I tried to restructure my idea based on the readings I did and also re-articulated the concept for more clarity and substance. During the project presentation, one of the classmates asked me whether it is possible to add 3D assets when we talk about interaction and manipulation. So I tried to use a cube that gives us the proof of concept that it is possible to do that, along with the rotational, transitional, and scaling of the physical space. And that's all. Thank you.